So last time we discussed that if we use op-amp directly without feedback, the gain of op-amp is too high, so we cannot use it for linear application as its gain is almost 10,000. So small difference in the input of two terminal of the op-amp gives a very high output, and so it goes in saturation that we are discussing that ideal voltage transfer curve of the op-amp. So to control the gain, we use feedback circuit. The first one is the voltage series feedback circuit, and second one is voltage shunt feedback circuit. So here what we do, the small part of the output is given back to the op-amp. We can give this voltage in two different ways. This is in series form. We are giving, this is the feedback, this is the feedback circuit, this is the op-amp. We get the output here VO. That VO is given to feedback circuit, and some part of that is connected to op-amp in series form. While in shunt feedback, you can see that op-amp and feedback circuit both are in parallel form. So here feedback voltage is parallel to the input voltage, and in series feedback voltage is in series with the input voltage. First we discuss voltage series feedback. It is also called non-inverting amplifier with feedback circuit. So now we draw real circuit diagram for voltage series feedback, or we can say non-inverting amplifier with feedback. I have already drawn it to save the time. So this is our op-amp, and this is the non-inverting input terminal, this is the negative input terminal. Here we get the output. So part of the output is used to give back, and this is your feedback circuit. This is the feedback circuit. This is the resistance called a feedback resistance RF, and this is the R1 is the resistor connected between inverting terminal and the ground. Here input is given at a non-inverting input, so it is called non-inverting non-inverting amplifier with feedback. So for this circuit we find out what will be the gain of the circuit. Before discussing that, we discuss three gains. One is called A, that is the open circuit gain, and it is defined as V out upon VID. That is the difference of two inputs, input at positive terminal, input at negative terminal, and take the difference, that is called VID, where VID is equal to V1 minus V2. Second gain we define is AF, that is the gain with feedback. Gain with feedback. How it is defined? Okay, output voltage divided by what is the input voltage? VO upon VE. Our aim is to find out what is AF in terms of our circuit component connected, that is RF and R1. And third gain, I say it is B, and it is gain of feedback circuit. Gain of feedback circuit. So we define three gains. Now, as we mentioned here, what is our output? Okay, A output voltage, output voltage VO is equal to, from this you can say that A into VID, and is equal to A V1 minus V2, where V1 is the voltage at the non-inverting input and V2 is the voltage at the inverting input. So here V1 is equal to V in, as you can see in the circuit. V in is equal to, here voltage we say V1, here voltage say V2. So if we take this output resistance of this supply is almost zero, or you can neglect it, that whatever the voltage is given here, V in, all appears at non-inverting input terminal. So this is our condition. If this is larger value, then all the voltage what we are supplying will not appear at non-inverting input terminal. So this is our condition. This is nearly good, or you can say that compared to input resistance of the op-amp, output resistance of the supply should be very small. Then whatever the voltage are given, all voltage appears at non-inverting input. So V in is nothing but V in. V1 is equal to V in. Now what is V2? So V2 is nothing but VF. VF. This voltage is given to here, and we know that for the conducting wire, potential at each point are equal. So V2 is here, it means V2 here, V2 is here, and V2 is nothing but VF. So we find out what is VF, voltage of the feedback, output of the feedback circuit. This is. So if I draw that circuit in different way to understand easily. So this is grounded, and here we give voltage VO. This is our R. I'm sorry, this side. This is VO, and this side I am finding VF. This is RF, and this is R1. So we are measuring voltage across R1 in fact. So this is one type of voltage divider circuit. So voltage divider circuit, then VF is equal to, we are measuring across R1. So R1 upon resistance of the closed circuit, that is R1 plus RF. This is according to voltage divider rule. We are measuring voltage across R1. So R1 upon R1 plus RF. And if we are measuring voltage across RF, then I have to write RF upon R1 plus RF. So this is VO. So, and therefore V2 is equal to VF is equal to R1 upon R1 plus RF is into VO. This is nothing but, as we explained earlier, gain of the feedback circuit. We can write B also if it is needed. So B VO. So substituting this value of V2 and V1 in this equation, I say it is 1. So what we get it? VO is equal to, VO is equal to A V in minus R1 upon R1 plus RF into VO, and therefore VO, break the bracket, I multiply here, taking that side, so it becomes A R1 upon R1 plus RF equal to A into V in. Our aim is find the VO upon V in. Is VO. I take VO common. 1 plus A R1 upon R1 plus RF is equal to A into V in. And therefore, VO upon V in is equal to A upon 1 plus A R1 upon R1 plus RF. R1 upon R1 plus we say B. So we can write A upon 1 plus AB. That is one form of this feedback gain. Gain of the upper with feedback here. That is in terms of A and B. Now again I modify this formula. I write directly here at this LCM. So it is here. A upon this R1 plus RF plus AR1. This is the numerator I take at the up. So this is R1 plus RF. Now we know the A is very large. So if we multiply with R1, it still become very large value. So compared to this, I can neglect this value if they are smaller. If you neglect, then my equation looks like that. This is nearly R1 plus RF divided by AR1. Can neglect AA, so we get 1 plus RF upon R1, and this is nothing but VO upon V in, and this VO upon V in is called gain of op-amp with feedback circuit, 1 plus RF upon R1. So by selecting the value of RF and R1, we can adjust the gain. But one thing is sure, for op-amp with a feedback circuit and it is non-inverting, gain is always more than 1. Because this formula is 1 plus RF upon R1. So by selecting the value of RF and R1, we can set the gain of op-amp. Suppose if I say RF is equal to 1K and R1 is 100 ohm, then AF is equal to 1 plus 1000 upon 100. So we get 11. So like that we can. And one more interesting thing is that if you give input to non-inverting, then output is also in phase. So output is in phase with the input. That is for non-inverting amplifier. So now we can use this for